Okay, thank you. So I'm Sidney. I'm currently a research assistant at EPFL, and what I'm presenting to you is, roughly speaking, my master thesis. So first of all, I would like to apologize for this rather long and academic title, which I will break down for you right now. So self-haptic consistency means simply that when I have an avatar in a virtual environment, when I touch one of my body parts, I want the avatar to show the same contact. Amplified embodiment, on the other hand, means that when I move outwards, I don't want the movement to look exactly the same, but I want the avatar to do more ample movement, bigger movements. For this to work, obviously we need some kind of motion capture system, and ideally also a head-mounted display, because what's the point in distorting the movement of your avatar if you have your physical hand in front of you to remind you what your actual motion was? But then you might ask, why should we care about movement distortion? Well, of course, it has some interesting questions about virtual reality. How do we react to a body that has distorted movements? How we relate to such a body in a virtual environment. But one of the main interesting concerns we have, something we could help with, is stroke rehabilitation. So the process of stroke rehabilitation is rather long and tedious. It involves repeated movement with a paralyzed limb. And in this regard, motivation is key, and serious games can already help, as was presented to you earlier this morning by MindMaze team. They have some technology in order to make the process more involving. And we believe that our technology will be helping even more in this regard. So, not the first time you see this graph, I guess. I would like to apologize to those who are familiar to this type of graph for my rather unethical and unusual use of it, but I hope it will make my point. So you have the ability and the challenge, as explained earlier, and the flow, that would be the comfort zone, what you are used to in everyday life. The thing is, when you got a stroke, your abilities are pretty low. So what you expect is some kind of task that presents a low challenge. And the issue is that for you to get better, you need the task to be quite hard. And so this gap between what you expect and what you experience during the training is what actually causes anxiety at first, and then leads to demotivation. So our technology of amplifying movements will help artificially fill that gap, at least temporarily, and help you continue with the training and perform better over time. So I hope I have convinced you that movement distortion is interesting. Now let's do a tiny bit of geometry, but it will be very simple. If I want to represent a point in space, let's say the position of my hand, the easiest way is to use basic coordinate system, x, y, z coordinates. But that's not the wisest thing to do in our case. Let's say you have something surrounding that hand, let's say some geometry, for instance, a table. Then what we can do is sample some points on that geometry and describe the position P as its position relative to those points on the table. So that if in my virtual environment the table is moving up and down, for instance, my hand won't sink into the table, but really stay on top of it. Now, instead of a table, what you could do, so that's basic stuff. If you want to discuss that, I'm pleased to do so. And now, if you, instead of taking the table, you take your own body, we get quite a lot of interesting properties, one of which is that we have successfully represented self-contact. For instance, in this case, if I hold my hand in front of my chest, then one of those vectors here, V, will be 0, which means we have detected a self-contact, and the avatar will do so as well, because it will have a 0 vector with respect to its own chest. So that's one of the key properties we are looking for. We want the whole experience to make sense and you being able to touch yourself. And on top of that, what we added is this deformation of the posture, this movement distortion. And based on what I explained, what I just explained you, the answer in order to distort the movement is fairly simple. If you, user, have your hand at some location, what we can do is simply alter the vectors describing the position of your hand, and we get an avatar here that has some the hand at some different location. So what does this look like in reality, which is not that real? For instance, here, the subject had to reach from a target that was on the leg to a target that was in the air in the virtual environment. And as you can see, the required distance to get the avatar to the correct position is halved. So the hand is in mid-air, and what the person sees in the helmet is the virtual avatar already has reached the target. So in order for you to see how it looks in action, we have a small video. So at first, no distortion at all is applied so that you get a feeling as to how it reacts. And then we apply an amplification. In this case, it's a doubling distortion. And as you can see, the movements of the avatar are indeed augmented and bigger, amplified. What we can also do, instead of applying some amplification, we can apply movement diminution. So in this case, we halve the movement, which means that in order for the avatar to cover a certain distance, I have to travel twice as far, which has other applications, not in stroke rehabilitation, but maybe in sports training. Yeah. So about the next step, so this is the technology that we have developed. And what we are currently doing is we are trying to understand, as I said, what kind of impact it has with the whole virtual reality experience. How do you react? Also, how far we can go with the distortion without you noticing it, or without it breaking completely your virtual reality experience. And of course, in the long run, that's what we already discussed previously. We'll have to understand exactly how this can help and what kind of parameters we have to include for the task to be meaningful in the context of stroke rehabilitation or in any other type of training application. And we also would like to issue some general guidelines, not only for stroke rehabilitation-oriented serious games, but really any kind of VR applications. Speaking of guidelines, we already have some preliminary results, so I can share some information with you. What we tend to find out is that self-haptic, of course, is important, but we have data to underline that. And the simple fact that it helps increasing immersion in the virtual environment should be meaningful to most of you, because it means that it leaves you more freedom to alter other factors, such as how hard it is, the challenge that is posed by some task, for instance, a physical one. Yeah, you can alter other factors in order to attain the goal you want to with your serious game or with really any training application. So thank you. If you have any questions, feel free.
Thank you. I'm thinking about the frustration people might have when they are doing a rehabilitation, and in the game they see that they can do something really good, and in real life there is nothing more in like a few days, because I think rehabilitation takes a long time to go through. And when you see you avatar can do something you can't do in real life. That may be a frustration for the person.
Yes, so it might be. As I said, we're in the early stages, and I'm nothing. I'm not an expert about rehabilitation, but those are effects that we can think about. There might be other type of effects. For instance, some neuroscientists we discussed this with suggested that the fact that seeing yourself doing bigger movements could have a beneficial effect with mirror neurons. So as we discussed before, it's a matter of balancing the negative effects of you being able to do more than what you know you can with the potential helpful effect you have on the training.
Thank you. Are you working only on amplifying simple movement, like, for example, just arms, or are you working on also on coordinating complex movement? For example, if you amplify legs movement, the whole body must go fast, and also arms have to follow the same rhythm. Are you working on simple movement or complex movement?
So currently we are only working on simple movements because of the way we have implemented the distortion. But we could imagine something where, as you said, we amplify maybe the speed at which you are walking or something like that. But currently we are only amplifying the movement with respect to your body and not with respect to the environment.
Thank you, Sidney. Okay, so now it is the time for the round table. So all the speakers of this session, could you please come and join us for the round table, and the speakers of the next session as well. That is the session on business, right? And the previous one? Oh, okay. So the same ones that were in the previous, yeah, okay. Okay.